The types of hypothesis. Non-directional hypothesis. A non-directional hypothesis, also known as the two-tailed hypothesis, is used to determine the change in the independent variable, for, and dependent variable, dv. It does however not indicate the direction of change i.e. whether or not the effect results in an increase or decrease. This type of hypothesis is usually chosen if the effect of a certain variable is being used for the first time. There are therefore no previous evidence to suggest what the results might be. Conclusively, a non-directional hypothesis in a correlational study predicts that there will exist a relationship between the two measured variables and not the direction. Example. A hypothesis states that there could be a difference between the levels of concentration of students who study in a well-lit room in contrast to a moderately lit room, with multiple factors influencing the outcome of the concentration levels, such as levels of brightness growing to be annoying and mental disturbance, and consequently low lights serving as a clause for distraction and lack of attention. It predicts a condition, yes, but not which one will be better at increasing concentration. Directional hypothesis. When previous evidence or previous research suggests the direction of an effect, of the IVs on the DV, it is then when a directional hypothesis is used. This is also known as the one-tailed hypothesis. This has different meanings when it comes to an experimental study and a correlational study. In an experiment, the best condition is to be determined, while in a correlation, the factor of the correlation being positive or negative stands. Example. If we refer to the aforementioned example, there might be evidence that a well-lit room determines more linear and focused attention as things are visually clearer. This is a directional prediction, and thus the hypothesis might be, students studying in a well-lit room have higher levels of concentration. It is also possible that a contrasting hypothesis could be tested as a directional hypothesis, i.e. students studying in a moderately lit room have higher levels of concentration. In a correlational study, however, if the case of a correlation between the amount of time a child spends consuming electronic media versus analog, print media, and their respective IQ levels. Conventionally, the correlation would be negative, as in the more time mindlessly consumed via e-media, the lower the IQ levels. The same could be said about the child consuming too much print media. That would however be conventionally positive, as longer attention spans do exist. However, a positive correlation would be the more time a child spends consuming e-media, the higher IQ levels, in the case that the child benefits from technology-based and interactive, being spatially intelligent that benefit from both audio and video, and negative in the case that the child gets bored quickly looking at redundant rote-structured learning. It is important to remember that your hypothesis should not say that one factor instigates a change in the other. Null hypothesis. This is implied when any difference between the for and the dv is so insignificant that it is likely to be caused by chance/coincidence. A null hypothesis is written with this in mind: there will be no difference in the dv between condition y and condition z, or any difference in the dv between condition y and condition z is due to chance/coincidence. Correlational studies need a null hypothesis because they predict the scenarios of no link or pure chance. It is important to note and state both levels of the for and dv, otherwise your null hypothesis will not make any sense. A meaningless null hypothesis would be, there is no difference between in learning via e-media and learning via print media.